If you guys think back a little bit to last week, right? It's Tuesday. So there's a full weekend in there. Hopefully remember a little bit of that. We on last Thursday we talked about I guess where we're going to start today is with lists. All right. So excuse me. So we're going to start with, just add a quick comment up here. Remember, right? Comments usually used to annotate code. For me, used partly to provide notes to you guys in the code that we write together in real time. Um, Helpful for you as learners. They're also used frequently in code to document for other observers, right? Other people on a team who might look at the same code or need to figure out what it's doing. They're worth including in your own code sometimes, or again as exercise submissions or something if you're not 100% sure what you're doing on the assessment. There is partial credit. For some exercises, you can get half credit if you're part way there and explain your thought process. So please leave comments in your code just in case. Anyway, though, to recap from Thursday, we looked at the list, right? Which is, again, defined using, in Python, a pair of square brackets, right? One to open it and one to close it. And then it contains any number of Python elements, right? Any data type in Python is allowed in a list. It doesn't care. The only thing worth remembering there, right, again, is that your code that expects the list or needs to process it later should be expecting it to have the right types in the right place, or you're in for some catastrophe, obviously. Right, here's a list. It has 3 integers, right? The integers 1 through 3. The string 4. And then finally another list, because we can put lists in lists. There's nothing wrong with that. Again, any valid Python type can go in a list. A list containing a single element, 5, is our 5th element. Again, you can have lists of lists. You can have lists of lists of lists. Obviously, there's a weird complexity issue at some point where it stops making much sense, but theoretically it is possible. So we saw on Thursday how we can access items from a list, right? Lists are ordered, which means we can access items by their position, their predictable position from the start. First element will stay the first, the last element will stay the last, unless for some reason we manipulate it. So in terms of how we might manipulate it, we saw earlier, right, on the first day, the idea of a method. We specifically saw some string methods, right, to uppercase or lowercase or procedurally format strings. And we're going to see many more methods here now for the list type. So there's a few important list methods that are worth us knowing. Firstly, if we look at our list to start off with, we'll see, right, it prints exactly as I have defined it here, right, with all of its elements showing. If we want to firstly add an element to our list, we can do so with the append method. If you look carefully, right, like we saw with string methods, the append method has a dot. It is called from a list itself. It does not need a list as its argument. That would be redundant, right? We have the list right here. It only needs additionally the element we would like to add to our list. Here, the floating point number 6.0. So if I run this, we can see as we go, right, Python reads our code top to bottom. We end up with first our original list, and then we can see after line 8, the list has been manipulated, right? We have this 6.0 at the end of it. We haven't done any reassignment or anything, right? This is literally the same list. We have just changed the data that it holds in place again, which means we didn't need to create a new list or copy it to add data. We have just taken that single list and changed it in our computer's memory so it has another element. All right. If you can see, the append operation happened upon the end of the list. So the order of the existing elements was preserved. They're still there in the same place. We just now have a different last element, 6.0. Obviously, we've added to a list. There's another method we can use that will remove from a list. So we can remove an item from our list. There's another list method called pop. P-O-P. And so if we finally print, I'm going to print our list, and I'm also going to print this element. Pop actually does return something. Append doesn't. Append's whole deal is that it manipulates our list. We don't need to return a new value. Our list itself has changed. Pop does return something, though. It will actually return the element it removed. If you look carefully, we now get one list, which looks suspiciously like our original list. And we get the value 6.0 back as well. This is our list now. This is the element we removed. By default, pop is going to work on the end of our list. It will take and remove that last element. Obviously, we need the ability to remove like other elements from our list occasionally. Which is also possible, right? We can remove a remove an element. I will just copy the same line of code here, but instead here, pop can take an index position as an optional argument here. If we don't specify it, it will just act on the end of our list, index -1, we can think of it as, but otherwise we can give it, for example, 0. Does anyone in the chat want to hazard a guess as what our list might look like after the operation on line 14 happens? What are we going to print right here when we print our list? So Marcus is saying 2, 3, 4, 5. Technically, Marcus, you are correct, except that 4 is a string and 5 is technically in a list. But your idea is sound, right? And we do end up with 2, 3, 4, 5, and then we get the 1 printed at the very end as well, as the 1 is now the element we removed that is returned by pop. All right, so now we can add elements to a list. We can remove elements to a list. We have some of our basic needed list functionality. There are a ton of other list methods out there. We can't in this course go into a super exhaustive list, I guess, of all of them. There is a remove method that behaves similarly to pop, can be customized a little bit differently. There is a sort method that will take a list and it will sort it, right? List.sort will sort the list by default using just greater than and less than comparison, right? So if we sort our list here, it will probably give us a type error because we can't compare integers and strings or integers and lists, but theoretically it should return again it should reorganize our list sorted if the elements are able to be sorted in some way. So there's a lot of other list related stuff out there if you are curious. Otherwise, we're going to actually jump to a different use case for organizing our data in Python in a different data structure built into the language that can help us a little bit, called the dictionary. All right, so in Python, we have what's called a dictionary. And Python dictionaries are defined using curly braces. All right. Instead of, again, the square braces, we just need to keep using different open closed characters. Eventually we'll run out, but this is reserved for dictionaries and sets. If you've taken math and remember what sets are, they exist in Python as well. They also use the curly brace. We'll see them in a little bit. They're just a little bit different than dictionaries. So the difference between a dictionary and a list really is that the lists are obviously, they're an ordered data structure, right? They have a first element, they have a last element. We store and organize our elements by position, right? The first one is the first one, the last one is the last one, the fifth one is the fifth one, and that is their sort of meaningful organization, right? That's it. Dictionaries are kind of the opposite. Dictionaries are for values we need to store associated with a specific key or some specific type of key, right? So it's for associative data, right? Not just values, but values that really need some sort of label to be relevant to us. In Python, to define a dictionary, we create keys. And then to create a key value pair, we create a key and a value separated by a colon, the key on the left and the value on the right. So key colon value. In Python, this is the second key. Let's see, we can use none. Whoops. I'll move this over a little bit. There we go. In Python, values can be any type we want, just like list elements can be any element we want. Python keys can't quite be anything. Python dictionary keys must be what we call immutable, meaning they are not able to be changed in place, which means keys are not allowed to be lists. Keys cannot be dictionaries. Keys can only be immutable types, which means strings, integers, floats, right? Things we can't change in place and have it be the same element. Tuples also immutable. You can make dictionary keys tuples if you so desire, which kind of makes sense, right? A mutable type can change over time. We don't want our keys to change over time. We want to look stuff up correctly and predictably by some value that like won't change on us. Imagine having a list be a key to a value, append to it, and then not know how to look up something because your list has changed. Real quickly, we can also use the dict, D-I-C-T function to construct a dictionary, just like with all the other types. If we would like, if we don't want to just use a pair of curly braces, we can use this more explicitly. So if we print our dictionary, we will get what looks exactly like this, right? The string representation of a dictionary, like with lists, is pretty predictable, right? With all of our string keys, technically any immutable type will work as a key. Strings are usually it, just because for a human, right, these make the most sense. Some human readable and human thinkable value to access your data, right? But as we see, every value is a corresponding key. Dictionaries are not considered to be ordered, right? They are unordered. If I run my code multiple times, yes, you're correct. The keys always print in the same order. Unordered does not necessarily mean the dictionary won't keep showing itself to us in the same order in my console. It means that we don't have a way in Python we can access a first element or a last element. We can't look up any element from our dictionary by its position. We have to use the key. That's what ordered kind of means. All right. To access a value, Just like with a list, we can use square braces. The only difference is that here we pass, instead of an integer position, we pass a key, right? So our dict at the key Greg should give us back this value, right? 9001. So on line 22, if we print this, we do get back, right, value 9001. So we can access any value by its key if we so desire. There is an issue here, though, which is that if I try this with a key that doesn't exist, Python gives us this exception called a key error, which is not ideal to us. So instead, if we would like, there are some dictionary methods we can use. There are many fewer dictionary methods we can use to handle some data access. Again, there are fewer dictionary methods, partly just because they're unordered. So you really either store data with keys and values in them, or your use case is different, but they're a little more method-wise, they're a little slimmer than lists. We're going to go over a few methods, again, just for accessing our data. And the first one we'll see is the get method. So the cool thing about our dictionary get method is it behaves like this normal accessor syntax, right? It will let us go in there and pull out a value by key, right? Get takes a key, it returned me, it looks like 9001. Again, the thing about dictionaries, if you think about it, right, if we have an associative data structure, right, keys and values, sometimes we may end up trying to look up a value that doesn't exist from a dictionary. And so the get method exists built into the dictionary to handle what happens if we don't have the key. So this worked fine, right? I got 9001 back. If I just sit on my keyboard for a second and give this a key that doesn't exist, we won't get an error or an exception. We instead just get back none. And the utility of get is really, it's a little more fault tolerant. If we try to access a key that doesn't exist, instead of halting execution of our code and spitting us back an exception, it just returns none. Or at least that's its default behavior. If we want some custom value back, get can actually take an additional argument, something like false. Let's say for some reason you might have none value in your data, so it's not easily the best way to tell, like, does this exist? Does this not exist? And we can replace that. We can customize what this default value it spits back is. For example, here we can make it false, right? So now instead of none, I get false. You index lookup, Marcus. Nope, we cannot use an index to look up. Again, dictionaries are unordered, so it has no concept of first or last or like an index position. It only understands the idea of keys and values. So again, it will present it to itself every time, but our dict.get3 will give you back probably none, unless 3 is a key. All right, so here we'll just get back none because 3 doesn't exist in the dictionary. Or for example, if we do 1, right, and we're like, yeah, we'll get back key 2 and none. That is not the case. We'll just get back none because 1 is not a key in the dictionary. Good question, but again, usually if you're using positional orientation like that, you'll just not use a dictionary. They're specifically for like labeled data, right? For example, if you have data related to a person, you need to store, you know, name, email, address, something else, age maybe. Like looking up the first element of that isn't nearly as easy or helpful to a user as looking up like name, right? The entry for name or the entry for email or the entry for something that's a little bit easier of a tag, instead of remembering like, yeah, I know email is the 5th element in this list of values. Every time I need email, I'll look up like our person list index 5. Does that make sense? So they're just different, completely different use cases um, instead. Um, cool. So in addition to there are other methods that will help us get like some sort of subset of our data if we want to. Or even Marcus, like you mentioned, there are ways to get not just values from key technically. We can access all keys or all values if we want, and this is sometimes necessary. So, for example, we can print. There's a keys method, and the keys method will return us something that functions like a list. It technically isn't a list. It's a dict keys object, which behaves exactly like a list. Behind the scenes, it technically isn't a list, but it behaves a lot like one. So for our purposes, it could be a list. This will give us back all of our keys. So if we look at it right, we get back this dict keys object that has key one, it has key two, and Greg are 3 keys. These are now ordered, so we can now, if we need to figure them out in order for some reason, we could use that. There is also, as a counterpart, there is our values method, which will instead return us all the values in a dict values object, right? It gives us back these 3 values. Does anyone have an idea why the values method is frequently like not super useful? Why might that not, in a dictionary standpoint, why might that not be especially useful? Any ideas? We have no takers. It's really just because, again, if your dictionary is organized by key, those keys probably mean something. Getting just values is honestly just frequently not that helpful, right? Like none here may mean nothing to me without the key. I don't know, like, is this none, is it like, what does it correspond to? So you'll see this a little bit less, but it can be useful once in a while for like specific things. Alternatively, there is another method that will get us all the key value pairs, Marcus, like you were mentioning. If you can look up pairs, you can't look up pairs individually, but you can convert your dictionary into a positionally organized data structure instead. And that would give us that would be our dot items method. And that will give us all of the key and value pairs in our dictionary if we so desire. Again, this is a dict items object. Technically, if we don't want that, if we want like a list, we can always wrap that in a call to the list function. It will create us a list. So here we will get just a list. And if you see, this presents itself like a list of tuples, with the key being the first element and the value being the second element. So I got this, right, key and value, then this key and value, then this key and value. So Marcus, to sort of long answer your question, you can't do an index lookup directly from a dictionary, but you can do an index lookup from what the items method returns as key value pairs as tuples. But then you just lose the key indexing functionality. Yeah. So if we want to, You can iterate through it if you want, just like a list. So items will return you basically a list. You could iterate through each tuple, or in a for loop, if each element has two values, we can actually unpack them both into two variable names. It also works with 3 values, 4 values, whatever, like XYZ in tuple of 3 elements. But we can get this, right? Here's our keys, here's our values, but together, right? So we can do that. It's, again, just a slightly more roundabout way to do it. And in a dictionary use case where your keys are meaningful, this is less likely to matter too much, but it can. All right. I will comment this out for a second there, just for ease of keeping my console to a healthy minimum. Cool. Lastly, if you want to add an element to a dictionary, this is actually, unlike a list where we need a method, this is incredibly easy. To add an element, we simply use the name of our dictionary, and then we just put in, instead of the accessor syntax where we just had a key that existed, we got back the value. Here we just give it a new key and an assignment. So our dict at new key is going to be equal to the string. This is a new value. Oops, and if I print it, see, right, we now have this new key and value in our dictionary, which is nice and helpful. There is an issue here. If we give our dictionary an existing key, we will overwrite the existing data. So now we still have the same 3 keys, but I've overwritten this one's value. All right, so this isn't, you won't get an error, but also you may not readily know that you've overwritten a key. So it may be worth checking first to see if it exists. All right, because the same syntax to add to write will overwrite if you give it an existing key, and Python won't let you know otherwise. So it's worth keeping tabs on that. All right. We're not really going into sets in this very short course. It's good to know they exist, though, partly so that you understand what happens if you create a dictionary without keys and just values, or like if you see it written on the internet, a set can also be defined using curly braces. The only difference is it doesn't have key value pairs like a list. It just has comma separated values. So if we want to create a set, we can try to create a set with curly braces and comma separated values. The issue is sets can only take specific types as their inputs. Sets can't take the mutable types, dictionaries or lists, as inputs. Set values like dictionary keys must be hashable types or immutable types in Python. So I added a list. It didn't work. I can only here put in integers, floats, strings for now. Right, so this will work. If anyone remembers from math, in Python, our set behaves really like a collection of unique values. It won't store duplicates. So if you look here carefully, we have 32, 3.05, and this is a string, the string. We end up with only 4 values. All right, all of the 3's, including 3.0, which is to Python considered basically the same value, they all just end up being just 3. All right, we get 1 occurrence of 3, that's it. And so we end up here with just this set of 4 values. Again, it only stores unique values from partly through an implementation sense of how it stores things in your computer's memory. But we're not really going to go into this otherwise. And if it's confusing that both of these use curly braces, again, right, Python picks up based on the key value syntax with the colon. We can also use set function if we want to create a set instead of having to, create the right, use the right syntax between dictionary or set. So there's another Python operator now that we've seen a few different compound data types, right? Data types that can contain multiple different elements. It's worth exploring. This is Python's in operator, which checks just for inclusivity of an element in a collection of elements. For example, and this is nice because again, it's not, like a numeric or condition or a comparison operator that's a symbol. This is an English language keyword. And it reads like this, right? So if we print 8 in and then this, what do we think is going to be my output on line 49? From the Python expression 8 in and then a list of 1, 2, 3, and 80, the integers. Any ideas? What might ultimately line 49 be printing to me when I run this file? No takers? So we get back false. And that's really the way the in operator works, is it just checks to see if thing is in collection of values. All right, 8. The integer is not in this collection of values in this list, right? 80 has an 8. That is a visual coincidence. This doesn't count as yes, right? 80 and 8 are different values, so Python says no. With dictionaries, we can do the same thing, checking by key. So if we use this expression key in our dictionary, if we look at our dictionary, there's a key, K-E-Y. So here we get back true, right? This key is present. The in operator, however, does not work with a dictionary to check of values. It will only check keys. So, right, none in our dictionary, even though none is a value, then the dictionary will give us back false. If we would like to make this work, we can always use a dictionary values method. This is one place that calling the values method might make sense, so that we can check if a value exists in specifically its values, then we get true. All right, so checking it against the dictionary doesn't work. Checking it against this obviously will, right? Because this is a collection of just the values. It works like a list. It also works for sets, right? 3 in our set, right? There's a bunch of 3s, but at the end of the day, there's 1, right? So 3 exists in our set. This will give us back also true. And then finally, this even works with strings. I can try, let's see, the letter D exists in our string. Python will tell me, right? We get true at the end here. Yes, the character D is present in this string. We can even do it with substrings, or collections of characters in a row. With a string, as long as they are contiguous, Python will say yes. If we added like a G in here, this would not make sense. So does this whole pattern exist in our string? Sure. And it's just a nice, easy way we can in Python figure out, all right, do, you know, can I check if this exists in here, right? Inclusivity. So now we're going to sort of take these compound data structures sort of to their logical conclusion. So we've seen how to add, remove, and access elements from dictionaries and lists. I mentioned earlier, right? Lists can have lists as values. They can have dictionaries as values. Dictionaries can have lists as values, which can have dictionaries as values. So sometimes you end up with weird, complex, compound data structures. So like a bunch of different Python data structures at once. It could look, for example, like this. So we could have a key that has a list as its value, or we could have a key that has a dictionary as its value, with another key in it that has another dictionary as its value, and maybe a value of 90 in there. So you can end up with sort of weird nested data structures that look like this. None of the all of the things we've learned so far about accessing data in lists or dictionaries still hold constant. So for example, we can access a bunch of different elements from here if we so desire. So we're going to take a look at accessing just this list first, and then specifically this 2, second value from our list. And then finally, how do we get all the way in here to pull out this 90 as a value? So does anybody in the chat want to take a stab quickly at how we can, in this review dictionary, access this list value, right? How do I get back that list specifically from our dictionary? What syntax would I put on the right hand of the assignment operator here? Anyone? I'll give you guys a second or two to try to figure it out. So that list value on line 57. Yeah, so we can use review and then square brackets and then the key one. So that's easy. How about we get the second value of our list specifically from start to finish, right? We can't do list value index 1, that's cheating. So how do we get from review all the way to that list value? What do I have to add to the end of line 66 for that to work? Any ideas? Marcus, you're close. It's honestly a good way to think of it. Yeah, Marcus, you're close. The second index just goes at the end, not inside the brackets. So we end up with review, key 1, index 1. So the way Python actually reads this from left to right is, all right, review. So here's our dictionary, review key 1. All right, that refers to our list. As far as Python is concerned, this is just the list now, and we can keep going to, right, this is the list. Finally, this is our index 1, the second element, and this should print us out 2. So take this to sort of its logical conclusion. How would I print, or how would I access this value 90 right here in Python so that I can then print it? Anyone want to try to take a stab at this? Review 3 key to 0. It's not a bad thought, Marcus. Remember, the thing associated with key 2 is not a list, so we can't use index 0. And this key 3 is within a dictionary, right? Review only has 2 keys, key 1 and dictionary, so we got to start with one of these 2. You're basically there. So it's going to look like this. We're going to go with review, and then we need, all right, review, I guess we need key dictionary. And once we have that, we're going to need, all right, well, we need, the next thing is here is just one key, it's key 3. And then finally in this dictionary, well, there's one key, it's key 2, and then that should get us all the way to this value 90. All right, and if we print it, we do indeed get our list, and then we get 2, and then we get 90 as these 3 different values. Theoretically, we could keep going, right? Make it even crazier nested data structure. Hopefully at this point, you kind of get the idea, right? If you can access elements in here, you can access elements with a little patience and tracing through of where everything lives pretty easily. All right. Any questions thus far? Cool. If not, then we'll get to our last, but probably most interesting or important. Well, I don't know that important. Maybe most useful topic for this course, which is going to be functions. All right, we've seen some functions in Python. We've seen, I think, some. We've seen length. We've seen dict. We've seen set. We've seen int, string, float. At least we've heard they exist. We've seen print. We've seen, that might be it thus far. We've seen all of those little reusable bits of code, right? Functions, again, they're reusable code. The ones we've used so far are built into the library, so we don't have to write the sum code or the length code or the print code on our own. These are things we might want to do often. They've been bundled up in the library so that we can use their name, give them data, they'll do their thing. And so we can create our own functions if we want to make some of our own code reusable. To create a function in Python, we use the def keyword, which will define a function. So you can use def. And then the way they work is we give it a name. So we'll just call this one literally function underscore name for now. This is whatever name you want that hopefully helps illustrate to the reader a little bit of what the function does, right? Print illustrates what it does. It prints whatever its input is to your console. Sum, right? It gets the sum of its input. Length gets the length of its input, right? It's len for short, but it's descriptive enough. So we define a function with a name, and then we define its parameters, right? What does it need as inputs? Later, these will be values we have, but in our definition, we need to give them placeholder names. So here I'll just say we need to take in 2 different parameters, A and B, and then do something with them. You could simply create a function that looks like this. So we'll print A. And then now that I have to find it, I could call it. With an actual input. we'll actually need 2. So we'll give it 2 inputs, this string and this 8. This will end up being A, this will end up being B. All right, so Python just matches up whatever inputs you give it 1 to 1 with these variable names, and then as far as it's concerned, you're good to go. It will do whatever exists inside its body. Again, we have an indented block of code. This will be the function's body, whatever's indented here. Right now, we just print A, right? So we should expect this to probably take this thing and print it to our console. We'll see it does, right? I called it, again, invoked it, which some people say. Usually people say call, but invoked is synonymous with call in programming. We can keep reusing it with its name in parentheses. If you want something a little more complex, we can instead use the return keyword. And this actually lets us capture the function's output value and use it just like we've done with assignments all over the place. So here we can, for example, return A plus B. And I'll change this so I call it with, I guess, 2 and 8. So now this is a function that will add 2 numbers together. If we run it, we see that return doesn't print anything to our console, so we won't see it. What return lets you do is assign the value that's returned to a variable name and then use it. All right, so we get back some value. We can print it if we want. We can use it in other computations or whatever, but ultimately here we get 10. Right, we take in 2 and 8, and we return 2 plus 8, and we return 10. Return 10, we can print it, we get 10. Right, I can keep printing this if I want with, we'll just call this output 2 with different values, right? 200 and, I don't know, 812. Right, and we can keep reusing this code with different inputs instead of having to copy paste it each time we want to use it, which is obviously much easier and much more efficient than not. So here we have this output and output 2. We've captured via the return keyword from our function. This is a very basic function. It just takes 2 things and sums them. Technically, if you remember how operators work, this will actually work with not just integers, it will work with, or not just numbers, it will work also with strings. The behavior is just different, right? It's concatenation. So here we get the string 2000812, right? It uses the concatenation operator, the plus sign, to just tack them together. But theoretically, right, this function by accident will work for strings as well and just do something different. Once we get the swing of, inputs to a function and then returning an output, we can theoretically make a function that does anything. As long as we have the right number of inputs and we return the right thing at the end of the day. For example, we can make a function that will take in a list and return the third element of said list. How might I return the third element of our input list called A underscore list? How might I do that in Python? Any ideas? What might line 82 say? So that I can, yeah, Marcus, you're right. So simply return A underscore list, index at element 2, right? Again, 0 indexing means that element index 2 is actually the third element because the first one is element 0. Cool. So if we call, for example, get third with a list of like 1, 2, 7, 9, and 100. And if we actually print the output of this function call, we can, again, this expression, Python will just figure out what this means, right? What it will resolve to, and then pass that to print. So we don't necessarily have to go through this assignment, pass the variable name to print if we don't want to. Ultimately here, we should get back 7, right? Third element. You take in a list, we get back the element at index 2, 0, 1, 2, 7. Cool. What's wrong with this function? What could we do to make this function better? Any ideas? What issue may this function have at some point in its lifespan? We want our functions to be reusable, which is always fair, but unfortunately, this function is not perfectly reusable. Can anyone think of a scenario where our function will not return us a value or will give us an exception as currently written? This would be one. It's a list of one element. We're going to get an index error. So this function doesn't work perfectly. But using Python that we have learned thus far, we can actually put most of these concepts together and make this work. Right? If we want to make this work for any list, we can use our try except behavior from last Thursday. So we can actually, just tell Python, all right, try this. If you get an exception, specifically if you get an index error, if you get another exception, I want to know, so I'm not going to mask it with except. We will return. For now, I'll just return none. That works for me. Right, so that now if I call this, it'll work, and I'll get back none instead of a Python exception. I'll get back some value that tells me, Greg, your list didn't have enough elements or something, and then I'll see it and understand. All right. So now we have a slightly more fault tolerant and more reusable function. So lastly, to just kind of put this together for a another function, we're going to make a function on our own that will, and we can just create functions ad nauseum if we want. We're going to make a function just to compute an average. All right. And we'll take in a list I'm just going to arbitrarily call element list. Again, these input names, you come up with those on your own. They should be descriptive as to what the different parameters are, right? AB, we didn't really need much descriptive here because it's 2 lines, and by the time I've read these, I've kind of seen the return anyway. This is helpful. It at least tells me I'm taking in a list. Here we have an element list, which again is a list of arbitrary elements. To compute an average, we need 2 different things, right? We need a sum, we need the number of elements. So we can start out by creating a total. Does anyone recall a way we can create a total or get the number of elements in a list? So we can start off really with the really basic from scratch using no other Python functions way to do this. Right? We can say for I an element list, kind of like we did already with a sum, right? On, I believe, Thursday with iteration, right? Total equals 0 for I an element list. Total plus equals I. And then we also need to know the number of elements. So we could also add all right, I'll use length equals 0. And so for each element, we will both add the element to total and also add 1 to this length. All right, so we'll have total is going to be whatever it is, and length is going to be whatever it is. Once we have these two, right, say a total of 40 and a length of 8, we can finally return our average, which will look like return total divided by length, again using our division operator. All right. So if I want to call this and see if it works, and compute get average with like 1, 5, 7, 800, 231, 4, and then 1 again. We'll probably get something in the realm of 350-ish, so something like 80 something, 85, 88 maybe. My best off the cuff guess. Whoops, I forgot my underscore. There. If I run this code, REPL's gonna take a second, as it sometimes does. Apologies, using a cloud-based service means that occasionally it takes a second for them to run. As you can see, if it says stop, cool. We get 50.0, really? 50 times 7. Well, that does make sense. There's like not 4 elements drag. All right, cool. So we end up with exactly 50 as our average. If we really wanted to figure it out, we could, look, but this is, again, going to add up to roughly 350. 350 divided by 7 should be 50. All right, so it looks like it worked. Obviously, we could always test it with better values than this. It's a little more easily predictable, but I get the idea. If we want to, right, this is using much of the behavior we have learned, right? Mathematical operators, some of the assignment operators. Like we saw briefly, iteration, right? Variable declaration, and a function. We can actually rewrite this if we really want to, using Python's built-in functions in one line. So we could say def simple average, the simpler way to write this, which would look like this. So return sum this divided by length list. All right, but doing this is good practice, right? To put together the little building blocks we've learned thus far to achieve a slightly longer form problem. Quick note, as I've been going through this course, I have, every single time I needed an indent, I have indented twice. REPL, their default indentation is going to be 2 spaces, probably because we have a file browser, a console, and a text editor here, where REPL prefers, to keep things a little bit cozier so that your lines don't get too wide, which is fair. Python has an actual style guide out there, which decrees that for all Python indentation, we use 4 spaces. So REPL will actually run with 2 spaces fine. I guess it decides that Python style guide is less important than space efficiency, which is for them fair. I have kept to 4 spaces no matter what, because Python says you should leave your indents to be 4 spaces if possible. So again, I've done that the whole time as possible, just so it looks correct, I guess, the way Python is supposed to be written for us. Just as an FYI for why there's, again, 2 different bars here denoting a tab. All right. Again, it will run with 2 spaces, so no worries if you write code with 2 spaces in the exercises. But if you think through it, if you try to remember, doing it with 4 spaces is considered the correct or more professional way to write Python. All right. Otherwise, do we have any questions about any of these topics or any of the topics from the other 2 sessions of Intro to Python? Any other things you'd like to see an example of or like to go over? Yet again, I'm happy to do so. I also just posted a link to today's notes in the Zoom chat. You'll get a follow-up email that also concerns that. All right, Marcus, which problem did you have a question about? While loop problem. All right. So let me syntax on how to solve it. Cool. So let's jump on into it. So if I go to Teams, because I also enrolled myself in as a student just in case. So this one, Marcus, awesome. Well, try accept. So this problem, thanks REPL, when it loads. Awesome. So our instructions marked down over here. Now that I've seen it, I can move back to the code. It says simply the user or grader will input integers until they input the string. Done. If the user inputs a value that cannot be converted to an integer, the program should ignore it, which can be important. Otherwise, the program will then print the sum of the integers. So for example, if we type in 1, 2, 3, and then done, we should get back 6, right? Because 3 plus 2 plus 1 is 6. If we type in, let's see, if we type in 0, the string 1, to the string 3, 4, and then done, we should get back 6, right? Because 0 plus ignoring this plus 2 plus ignoring this plus 4 is going to be 6. All right. As a reminder at the bottom saying that the exception raised when int fails to convert a string into a numerical value is a value error. I'm just going to copy this just in case because it sounds like it's noteworthy. Cool. So in Python, the input statement will simply wait. And we saw it at the very end of the first day. It will wait for the user to type in input, and then it will return whatever they type. So I'm just going to quickly run this while loop. You will not run without ending quickly simply because it has to wait every time it hits line 3. So as I type stuff in, it will just return it to the name user input each iteration of our while loop. All right. Use Control C to keyboard interrupt and we'll be done here. So this is going to be our user input. So what we need to do essentially is take our user input and make a sum. Let's start with just the sum. So each time we need to gather a number from our user and then add it to the total, right? So we already have the total defined. We're already printing it at the end. So all I need is to convert it, right? This is going to be a string. Input always gives us a string, so we need to convert it to be, probably use a float. Let's say integer. All right, integers, so I'll use an integer. And then add it to total. All right, so I'm in one line with total plus equals int user input. Or I could do it if I wanted to on 2 lines with converted input equals in user input total plus equals converted input. All right, both of these would work. This is the 1-line way to do it. This is the longer 2-line way to do it. Let's run this, right? I can keep adding stuff here, but honestly, this isn't going to work because as I keep typing numbers, we're still going to loop forever, right? So we need some way we can break our loop. So we need to add a condition here. If, so we'll start all the way up here. So the README says, right, if the user inputs the string done, D-O-N-E, in all lowercase, we will stop our loop. So if user input double equals, so if user input double equals string lowercase D-O-N-E, we can then, if we would like, break, right? Keyword that will end our while loop. So if I stop this and rerun our code, we should now get 1, 2, 6, 1, 1. Should give us back 11. If I type in done with the right casing and hit enter, we get 11, which is the correct total. All right, 6, 7, 8, 9, 11. This is a good start. We're just missing one other there should be one other little wrinkle to us, I guess, right? So we're checking user input to see if it's done. The issue is still this, right? If I type integers, we're all good. If I type literally anything else, you get our value error. So Marcus, do you remember what type of Python behavior we can use if we get an exception we might sometimes be okay with? Yeah, we can use try and accept. So this line will sometimes give us an exception, which is fine, right? We can try this. In the instance of a type error, we can do something else. Or we can use pass if we want to, which we saw, I believe, on Tuesday, I think, to do nothing. We could put when the user input is not a string or int, we get the type error. So we get it when it is a string, but specifically not this string. Does that make sense? Because if only cares about this, and then if it's not this, we continue. Technically, Marcus, the input function will always return us a string, no matter what. So every single time input returns a value, it returns a string of whatever you typed in. And then so, let's see. Oh, cool. You know Ruby. All right. Yeah. So it would be basically the same as, it's just that idea, right? This is I mean, theoretically, we could use the global except or something too, but type error is obviously better. But again, this always returns a string, so we're not going to get any other types. The only three things we need to control for here are specifically this string, an integer, or anything else. All right. Does that make sense? Would you like this snippet for your own records? Do you have it already? I can't send you this REPL because it's an exercise. So like obviously REPL does privacy things with that. Marcus, actually, is your name on Discord related somehow to Marcus? Is it M Quintana 95? All right, cool. I sent you a quick message and code snippet. Congrats. The proud owner of this new code. For anyone else who wants it, I just copied it in here too. It just isn't nice and formatted like Python, and it will disappear when the call ends. No problem. Otherwise, any other questions about either an exercise or a topic we covered that you would like another example of, or anything? If not, then thank you for attending these 3 sessions of Intro to Python. Again, the assessment will be posted promptly Thursday at 6:00 p.m. Eastern time, same time as all these other sessions, all these other calls have happened thus far. The assessment will actually live right in here where the exercises are. You will just get 2 new categories of exercises called, I think, assessment part 1 and assessment part 2. Each will have 5 questions. If for whatever reason you are interested in taking any of Byte Academy's boot camps, full or part-time, the score you need to get on the assessment is 3 from each section correct. So you need to get 3 from each section correct. With partial credit, though, you can get half credit for answers you mostly get correct. So I encourage you to answer as many as possible. The 3 counts partial credit. So if you get 1 and then 4 halves, that technically will count for a section. But you will need 6 of the 10 total to pass for admissions to any of Byte Academy's boot camps. If you don't care about Byte Academy's boot camps and want to take it, you will need the same to pass, right? That is the sort of passing grade. The assessment is technically, it's not more than we would expect someone to be able to finish in 2 hours. Some people could, but it's a lot for 2 hours. So in that 6 to 8 time frame, you only need to get 3 of the questions in each section correct. All right. I'll throw a message in the Discord server so that y'all remember and get a message, but it will be right at the exercises link that you've already gotten. You'll get a follow-up email that includes it later today as well, but it will show up right there again at the bottom, just like these sections. It just obviously isn't there yet because it's the assessment. And when you start the course, we hide it so that you don't see it. But otherwise, again, Thursday from 6 to 8, I will be available via Discord. There won't be a call open to drop in and ask questions. I will be available via Discord if you have any specific questions that you need answered. And attentive for that entire 2-hour period. If you have issues finding the questions, starting the questions, an issue with REPL, an issue with phrasing of the question itself is fair game. Question about how to do something, probably not fair game, but you're free to ask whatever you want just in case. The worst that'll happen is I'll tell you I can't answer it, and then you're where you started anyway. So I encourage you to ask questions if you do take the assessment and feel like it. Otherwise, thanks for taking the course. I enjoy teaching it, so I hope you guys enjoyed showing up and taking it as well. As a follow-up to today, you will also get links to recordings of all 3 sessions so you can rewatch them if you need to or study. as well as a follow-up link containing the notes and code from today, as well as probably another exercise link re-upping just in case you don't have it or don't remember where it is. Try to include all the relevant links in that last session 3 follow-up so you have what you might need to study before Thursday. Otherwise, if there are no other questions, I will see you guys sort of semi-theoretically at 6 on Thursday, or at least we'll all be sort of virtually in the same place on REPL. Otherwise, if you have questions, feel free to let me know. I will again in the email include also my email and Discord user ID just in case. Thanks for coming though. Hope you appreciate it, got something out of the course. And good luck if you want to take the assessment on Thursday. No problem, folks.